Hello students. Today we are going to discuss the topic input-output organization under the subjects computer organization and architecture. Okay, in earlier video we also discussed all about the von Neumann architecture. In that we have seen all the components of von Neumann machine, and the major component was central processing unit and other components are also. So one of the most important component is input output subsystem, and also we know that why it is called subsystem, because it is supporting to take input and output from the external world to the central processing unit. Okay, so input output subsystem. The I/O subsystem of a computer provide an efficient mode of communication between the central system and the outside environment. It handles all the input-output operation of the computer system. Okay, so basically input-output is for the external communication for the central processing unit. Next thing is peripheral devices. All the input output devices are also known as peripheral devices, and why it is peripheral devices, because they are in nearby the periphery of the central processing unit. So this is the peripheral devices. Okay. These devices are designed to read information into or out of memory unit upon command from the CPU and are considered to be the part of computer system. So these are known as peripheral devices. The examples, we can say that keyboard, display units, printers. Okay. There are basically three types of peripheral devices, and first one is our uh, first one is this is input peripheral. Input peripheral allows for taking the input from outside world, and majorly keyboard and mouse are the examples. Second is output peripherals. Output peripherals are the for giving out the process data to the external world, and majorly printer and monitors are the examples. And thirdly is input output peripherals. Both work they can do they can use for the taking input and output. Okay, so these are the peripheral devices. Now third slide is all about the interfaces. So interface is basically for this is the sheer boundary between the two separate components of the computer system. So shared boundary between the two separate components of the computer system. If we want to connect two different components, then we need a interface for attaching or for getting the association of that two components. We need an interface. So basically there are two types of interface we can clearly see here: CPU interface and the IO interface. So CPU interface and IO interface are the basic interfaces which are in our computer system. Okay, now next thing is input output interface. So we are here in this presentation or in this video lecture, we are basically interested in input output interface. So peripherals connected to a computer need a special communication link for interfacing with CPU. In computer system, there are special hardware components between the CPU and peripherals to control or manage the input-output transfer. These components are called input-output interface units. Means these are those units which are connecting the CPU hardware and external peripherals. Okay, interface units provide the communication links between the processor, bus, and peripherals. Okay, so for communicating between the for getting the association in between the processor, bus, and external peripherals, we need input output interface. Okay, next is modes of data transfer. So basically clearly we can see that there are three modes of data transfer between the input output. As in our class lectures, we discussed already, we have a detailed discussion on this programmed IO, interrupt initiated IO, and direct memory access. Programmed IO, interrupt initiated IO, and direct memory access. So basically these are the three modes of data transfer between the input output units. Okay, now programmed IO. So basically it is very trivial method in which we are using the instructions for performing the input output operations. Programmed IO instructions are the result of IO instructions written in the computer program. Each data item transfer is initiated by the instruction in the program. Okay, and usually the program controls data transfer to and from CPU and peripheral. Transferring data under programmed IO requires constant monitoring of peripherals by the CPU. So CPU is playing major role here, and each input output activity is handled by the instruction. Okay, and CPU has to wait in this mode of the data transfer, because there is a very much speed gap, we can say, in input output devices and CPU. So CPU has to wait. Okay, this is the drawback of this mode. For avoiding that drawback, here is another mode, that is the interrupt initiated IO. And in this in the programmed IO method, already we have seen CPU stays in the program loop until the IO unit indicates that it is ready for data transfer. Okay, so a speed problem is there. This is time consuming process because it keeps the processor busy needlessly. But in case of interrupt initiated, this problem can be overcome by using the interrupt. In this, when the interface determines that peripheral is ready for data transfer, it generates an interrupt. After receiving the interrupt signal, the CPU stops the task which it is processing and serves the IO transfer and returns back to the previous processing task. So clearly we can see here that CPU, there is no need to wait for the IO activity. Or here we can say that whenever its input output is available, the input output devices interrupt the CPU and tell that we are ready, you can perform the IO activity. Now there is still some drawbacks. So all this is and performance issue. So lastly, there is third mode of data communication, and that is the DMA. DMA, full form of DMA is direct memory access, and in this all the we avoid the intervention of processor in the IO activity, removing the CPU from the path and letting the peripheral device manage the memory buses directly would improve the speed of transfer. This technique is known as DMA. In this, interface transfer data to and from the memory through memory bus. A DMA controller managed to transfer data between peripheral and memory unit. So there is no role of CPU, we can say. DMA already takes the power of buses by requesting the CPU, and it directly communicate with the memory unit for performing the IO activity. So it generally happens in disk drive controllers, graphic cards, network cards, sound cards, etc., and multi-core processors. So this is the main application areas of DMA. Now this is the block diagram of DMA. We can clearly see that there are basically two signals which are performing the DMA operations. Here we can see that this is the DMA request, and this is the DMA acknowledgement. So DMA request means DMA put a request in front of CPU for relinquishing all the buses or resources to it, and if CPU agrees, it acknowledged back to DMA, that is 8059. So that please use the buses, and DMA takes all the control on the buses and performance IO activity. So this is basically, we can say that block diagram for DMA, and this is the